Hi everyone, welcome to the Math Spellbook live stream. I'm your host Peter, and basically we are going to go into it today. Let me see here. So I basically updated my model a little bit. Oh, the study timer is going off. We shall turn that off. Let me just move my model over here for you guys so it's not too much in the way, or maybe I can just shrink it a little bit. And I just noticed that my model's mouth is not moving, so I might have to fix that, but let's not worry about that. Let's not worry about that right now. Yeah, I just basically my artist, basically she sent me a message and basically said, I updated your V model, and basically I just uploaded it on my VTube Studio, but I hadn't played around with it, so just pretend that basically not to pay attention to my VTube model's mouth. I probably just have to tinker some things, so don't worry about it. But I'm still communicating with you guys. So we're just basically gonna do some calculus review, because mainly Calc 2, because I feel like I have to review a lot of Calc 2 actually, just mainly for my own benefit. Let's see if we can. I actually want to clear everything here. Let's see. There should be board. No, I just want to clear it. I don't want to delete it. I'm pretty sure I was able to erase the whole thing. I'm just trying to remember how to do that. Set start, no. button where I can just click clear? No, I don't want to delete it. I just want to clear the whole thing. Oh, that's renaming it. Because it says new board, but it's like, no, I just want to clear the whole thing without having to erase everything individually. Yeah, and we have a lot of stuff here. Yeah, we have a lot of stuff we... to 100. Okay, there we go. Alright, so I think for today, what did we left off on? Oh, trig substitution. Like, I'll be going like back and forth with this, so hopefully you guys don't mind. Let me check some things here. Just put my model a little bit right here. Alright, so whenever I bend down it will fluctuate a bit, so I think for now we're gonna just turn up my model and then we're gonna go into the study timer. And let's go! Let's get started. Alright, trig substitution. So how much... Where is it? Pencil. So last time when we did trig substitution, we have to remember that... Oh, that is very thick. Let's reduce that a bit. Then just erase that. So x would be equivalent to sine of theta. And then a tangent of theta. Okay. And secant of theta. Okay. And for the triangles, theta over here. Oops. Probably draw that a little bit better. Yeah, I guess like for all of you guys that did calc, this is probably going to be like an easy day for you. And also I made a separate channel on the Discord. Like if you guys like pop in and want to if you guys see that I'm struggling and you feel like you want to chip in and help, just type in, you need a little help. You need a little help there. And I'll answer whether I say yes or no. If I say yes, then if you want to post resources, I made a separate channel on the Discord that will allow you to, the channel's titled, I actually have to remember what I typed for that channel. It is Stream Material Resources. So you can basically, like, if I'm streaming and you guys want to like post stuff to like help me out for visualization of the math, that's also fine. Just post all the resources you want to post in there, instead of like say the general chat or something. Alright, so that's basically the gist. Now let's see if we can start with the basics. So we'll do 17. I think we can shrink this here, make it bigger for you guys so you guys can see. And I think that's perfect. So you know what? I'm going to move the chat, instead of being up there, let's put you guys down here. I think that's better because sometimes I write upwards, so I think that's much better to do. Hopefully you guys like that placement actually. So we'll raise this up so you guys can see it better, because we don't pay attention to the bottom level. I just have to remember not to write too much on this side. Actually, what we can do, we'll put you guys over here since it's mostly like the textbook. That way you can see what I'm writing. And it wants to be fidgety with me, so I'll just do it like that. There we go. I think that's much better. Okay, number 7. Oops. I gotta click on my tablet for it to write. So we got 25. So I feel like I should do the parameters first, because let's see, we got sine of 5, because we know we're gonna have to change this to theta 25 by 25 times sine of theta. Now the parameters we have here, so then we're going to be left with 25 over here. Okay, good. I had my calculator with me, so we just have to calculate theta, which is sine of 25, which will give us let's see, the sine of theta oh wait, no, wait. Wrong arithmetic. Sorry about that, guys. So it will be 5 times. Is that 5 will be beneath? So yeah, that was the wrong arithmetic on my part. So it's not 20. I'm losing it. Half. Yeah, there we go. That's better. That's better. See, I sometimes make mistakes too. I make mistakes too, guys. There's nothing to be ashamed about. Sometimes mistakes just happen. So I think we'll make it. We'll do the radians. So we'll do pi over, well actually, I should write pi a little bit nicer. It's a number that deserves our respect. Pi over, so it would be pi over 6. If I'm wrong, you can put in the comments, that's the wrong parameter. So pi over 6, 0. Okay, perfect. Now, we'll carry on with the integral. Like so. So we factor out 5. Well, actually, we factor out 25, and then basically... Well, yeah, well... And then we're left with sine, like so. Then we'll change this to cosine, like that. I should put like equal signs to show you guys the line of my work, and I'll erase this because it didn't look that neat. Okay. Pi over 6, and we have 5 cosine. So now we have cosine of 5. We can't do u substitution because if we do u substitution with this, then we would have to differentiate with a sine. Well, what I mean is that we do u substitution, cosine would be equal to u, and then the derivative for u would be sine. So we can turn it into secant because it's like over, but at the same time, I sometimes don't remember that derivative from the top of my head. I mean that integral in from my head. There must be something I'm not thinking of. I know I'm missing something. What am I missing? Thing is that I don't remember this integral. Unless that's not a really great idea. I was thinking about doing like cosine of -1 to the -1 power, but at the same time I still have to do differentiate it, and I don't think that would help. Let me see here. I don't want to look at an example because I feel like I'm just gonna, it's kind of like cheating myself at that point. But I feel like I know what I'm supposed to do here. Oh, I just realized my study timer is like probably gonna get in the way of like our work as well, so you know what? Where is my... So let's just move it. Let's move it on this side for now. Yeah, because we keep all the books and stuff over on this side. Actually, we can put it up there. I know I'm moving a lot of stuff around, but I feel like the main priority is getting the work shown for you guys. The book I think is mostly secondary. I'll just like to get you guys to see it, I'll probably just like move around the book a little bit, so that way you guys can see all the contents of the book if we need it. Because the main priority is getting the problems. This. So sine. No, I mean cosine. Sorry. And we reduce that. Unless we were supposed to do... Oh, maybe I overdid something. Because I'm starting to think like what so cosine. Is that the right approach? Huh. Yeah, I think I'm getting like the ordering wrong. Let's see, that will turn into cosine squared. Then it will turn into cosine. I mean, technically there is no u at that point. Because if we turn that into sine and then we use u substitution to make it, to say that u is equal to sine, and then cosine, would that work? I mean, technically it's not against the rules, but at the same time, let's see if we can give it a try. So we have 5 and then cosine. Let's say u is sine, and then when we differentiate it will be cosine. See, this is why I need to review. And if you guys hear me, like, the way I'm talking, it's just because I have a cough drop in my mouth. I'm not sick or anything, it's just that I was streaming last night with my friends. We were playing, like, a game. And of course, like, when you stream, like, more often than you're used to, sometimes your mouth gets raspy. I mean, your throat gets raspy a little bit. Yeah, it's been a couple of minutes. I probably should, like, just take a look. I really hate doing that, but I don't know why I'm struggling with this. Yeah, it annoys me when I have to look up like where it is I'm stuck, and I'm like, what's wrong with me? I should know this. The way it looks like in the book, yeah, because we factored out 25, which give us 5. And then we were left with sine of the square, and then the cosine on the bottom. Yeah, because if we do use substitution, because the problem is that if we do use substitution, then we do this, and then we're going to be left with sine of theta and that doesn't help us. Maybe I'm flawed in my logic here. Let's see here. I think I'm missing something. I think I'm missing something with so let's see what dx is equivalent to, because x is equal to sine of x. That's what I was missing. Yep, that's what I was missing. See? Sometimes it just takes a little bit of deep thinking. I knew I was missing something. So then we can erase this. And then we're left with, and then that will just leave x, which is theta, and then theta is going to be, which will equal to over 6. But then we also have to put back the x, so this is based on theta, meaning so yeah, so therefore minus, yeah, which gives us that right there. We'll just box that in, and then now I have to remember what happens next. What we do? I mean, technically we got what theta is. Now I think we have to plug that in for like what we get for x. So because x is supposed to be equivalent to that, so technically that will just give us our answer. So yeah, so that works. So I guess we have to solve up to here. Like before I thought I had to like convert it. So if we do theta, and then if it's sine, then that means it's at the bottom. Oh yeah, x is supposed to be sine. So that'll be sine. Yeah, that would work actually. Okay. Yep. Okay, so I think we did number 7. Yeah, that's what I was missing. Okay. Yeah, because like I really like it when I have moments where I actually just figure out exactly what is it that I'm missing. And sometimes you have to like bang your head on it a bit. So better to visualize it that way. Okay. So we'll change it to, well, actually let's erase the parameters here because we're gonna have to convert it anyway. Then turn this into 9. Technically erase that. Turn that into a 9 sine squared. Like so. Then for d, for x, it will be equal to 3 sine theta, meaning that dx will be equivalent to cosine. So cosine. Okay. Sounds about right. And for the parameters, multiply that by a half. No, what am I doing? Not a half. It's supposed to be a third. And they're giving us that, thereby reducing it to make it a half, meaning that theta is equal to pi over 6 again. So it's pi over 6, and then 0. Okay. No problem. No problem at all. What else? What else is here? So now we're gonna have to do a little bit of manipulation here, which is fine. So first off, we're left with 9 to the third. Then we got 1 sine squared theta to the third, thereby cosine. So like this. And we're left with cosine to the second to the third. Which means we can split them. So we'll be left with 3, the square root of 3. Because then that would be like 27. And then for this one, we'll be left with just cosine with the square root of cosine. Because we are left with the square roots underneath here. And then that's a third, so I mean 3 times 2. Technically that would be a 6. So then we'd be left with cosine to the 6. I mean, these would cross out. And then we'd be left with cosine to the second, cosine to the second, cosine to the second. Oh. Then, so we're left with cosine up here. Square root of 3 down here. Oops. Let's just rewrite that like so. And technically you'll be left with cosine to the third. Yeah, because then you can like you can deduce that basically it'll be cosine, 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 and then basically you just multiply them together. I see. So this 2 would cross out, giving us d theta over the square root of 3 square root of 3 cosine squared. Okay, got the 0. Then we bring this up. Then we do so we got cosine to the second power. I think we can move this square root of 3 here. Yeah, we can move that out. Cosine squared on the bottom here. I think I'm going to try a little trick. I just thought of this. So cosine squared is similar to basically saying cosine and then since it's a fraction under in the denominator, we can flip it like so. And then we're left with 2. Oh yeah, don't want to forget the square root of 3 in the front. The 1 over square root of 3. Apologies for the terrible handwriting. So do that. And I think we'll just move the 2 out. Left with let me just bring this up a little bit. So we got 2 over the square root of 3 integral. Oh no, this is the denominator, so we can't do that. I was about to split them, and I was like, no, you can't do that. Did I make this more complicated than it is? Maybe I did. Just what is it that I'm missing here? Let's go back and see where I got lost at. Oh, maybe I did the wrong operation. let's erase all this. I think I did something wrong here. I usually like to erase everything whenever I feel like I want to try something new. So let's just erase this part here. Okay. So back to pencil mode. Soften the last one is that it will be cosine of 3. Now, oh, that is 27. So it will be 3 cosine theta over 27 cosine to the third. Then oops. So then this will go into theta, and then this will turn into 9 cosine to the square. Like now I'm just trying to think of my next steps here. Like I'm trying to think ahead of time because I noticed that whenever I do certain things and I go through the whole thing, I realize, oh wait, I could have done this and I could have done that. That is the part of like doing math problems that I haven't fully developed. It's just like thinking through every single thing. For me, I just do it and I basically just like realize that, oh wait, I'm doing something wrong here. And I have to go all the way back and I have to do all over again. Let's move that out first. We'll have a cosine. So we'll have a cosine on the bottom. Cosine squared, actually. must be something I'm not thinking of. Because if I split it to sine 1 minus sine, that doesn't do anything that much. Well, what must I do? I just had an idea that I was like, wow, why didn't I think of that earlier? So the integral of that would be tangent plus c, and then that's from pi. Therefore, we are given, and I think this is 1 over pi to the third, I think. And I mean, technically, well, actually we shouldn't have a c there. This is a definite integral, so in turn leaves us with no, not the square root, 1/3. Oh, it's break time. But yeah, like, yeah, I think that's it. Very well done. Very well done. I mean, it didn't help that it took us like 45 minutes to solve 2 problems, but I'm okay with that. I'm okay with that achievement. I mean, we just basically had to rack our brains a bit, like just basically just trying to figure that all out. Oh, okay. I think my mouth is moving. I think maybe it's because I didn't notice it before, because I didn't zoom in on the image of my model. But yeah, so I hope you guys are like enjoying that like slow process of just like basically just racking my brain on like just basically trying to focus on actually seeing the problems and trying to solve them like in a manner that is like I guess like apparent to me, because for me it's like I'm trying not to rush through the problems. In addition, like I'm trying to let myself find the connections like within my own brain, because I know most of you guys probably have a higher comprehension speed or like a puzzle assembling speed than I do. But I feel as if like for me, I have to actually like navigate myself to find the sections of where I am getting lost at. And I think that's basically why people do problems, especially in math and also physics as well. It's like basically just navigating the parts where you're stuck, and then basically trying to figure out exactly what is it, why you're stuck there, and what is it that it leads to. If that makes sense. You know what? Since it is break time, maybe I should like watch a lecture on I was watching something on partial differential equations. Like I was taking notes just basically just for my own like learning experience. But of course that doesn't mean I know how to solve problems involving the math. It's just that I want to be able to understand it a little bit, like get it, like, because you know it's like when you read a book and you read it for the first time and it doesn't make sense. but then like when you actually read it from a different source, it feels like you're kind of getting closer to understanding what the technicalities are. So, oh no. There we go.
Hello everyone and
Oops. Oh, this one's long. But we'll take some notes. And I think I'll just pause my music here. Then I'll just drag this down for you guys.
Hello everyone and welcome back. Now, in the previous few lectures, I built up a lot of momentum for the heat equation, right? We figured out how to derive it. We talked about boundary conditions. We even solved it a little bit with equilibrium temperature distributions. We talked about its theoretical properties, its linearity, but it's taken me a long time to actually solve the equation. So that's what I'm going to do in this lecture. I'm going to solve the heat equation with Dirichlet boundary conditions. Now, this is probably what you've been waiting for a long time, right? This is sort of the purpose of a PDE's class, is to solve these partial differential equations. And let me tell you, you're going to get sick of solving them very quickly because we are going to do a lot of lectures coming up on all the different ways that you can solve the heat equation under all the different circumstances. And the purpose for this is to, again, build ourselves up to a place where we can get to a theoretical understanding of the properties of the heat equation. This is eventually going to lead us to Fourier series, sine and cosine series, all of the sort of theory that underlies this. But for now, let's do some plugging and chugging, and let's actually solve this thing so we can see what the solution looks like. Now, I'm going to use a method called separation of variables, and I'm going to look at the case of Dirichlet boundary conditions. So let's take a look at this. Heat equation. I'm going to do it in a simple setting, so no sources.
I'm actually taking notes in my notebook for this.
A homogeneous rod.
So that way,
just a constant here. I'm going to consider myself.
That's how I usually do when I'm like trying to expose myself to a subject that I'm not familiar with.
Of course, I want time to go forward. And again, the equation is incomplete unless you give me boundary conditions. So a whole bunch of different boundary conditions. I said today I'm going to use Dirichlet boundary conditions. So at 0, the temperature is going to be fixed at 0. Similarly, at the other end of the rod, the temperature is also going to be fixed at 0. These are the boundary conditions, so the BCs. Okay, so take a look at this. These are linear boundary conditions, a linear equation. They are homogeneous, a homogeneous equation. And one more thing that I need is my initial condition. I am going to prescribe some initial temperature distribution. I'll just call it f of x for now, because it's not going to really matter, okay? We're going to get to that at the very end. But here's what we're going to do. We're going to use separation of variables to solve this partial differential equation. Now, separation of variables, very descriptive name. Separate out the variables. What are the variables that I have in my equation? X and t. So here's the thing I'm going to do. Set u equal to, and I'm going to use the notation from Haberman's book here, so phi of x and g of t. Now, this means that I am going to search for solutions that are functions of x and t that can be separated out. It's a function of x multiplied by a function of t. One time while I was teaching this class, somebody asked me, is it possible that you are missing other solutions? Now the answer to that actually turns out to be no, but the reasoning for it is very, very complicated, as we're going to see as we get into Fourier series. Now, separation of variables only works in very idealized settings. So for example, in our case, we have a homogeneous linear equation. We have it posed on a line. If you do this in higher dimensions, separation of variables doesn't always work. So again, idealized setting, but I still want you to be able to see the solution here so that you can understand what get some feel for what a solution to a partial differential equation will look like. Okay, under this restriction, if I take a time derivative of u, what do I get? Well, phi doesn't change in u, so it stays the same, and I get, let's just say g prime of t, okay? I'm just going to use regular old notation for derivatives here. And similarly, if I take two derivatives in space, then I get two derivatives of phi, and g doesn't change. So then, what does this mean for my partial differential equation? Well, let's put in these two pieces that we know. So I get phi of x times g prime of t is equal to k times phi double prime of x times g of t. Okay, so time derivative is equal to a constant multiple of the second space derivative. And here's what we do. This is where the separation comes into play. Because the fact that we were able to separate, or we assumed that we could separate out the variables, means that I could divide off g and divide off phi, and I could get this. I could get g prime of t is equal to over k of g of t is equal to phi double prime of x over phi of x. Okay, so I took the k onto the left-hand side with the time derivative piece. Doesn't really matter where you take it. This is sort of convention to put it with time. But take a look at this. The left-hand side varies with t, where the right-hand side varies with x. Okay? These are two completely different variables. I can choose any value for x. I can choose any value for t. This ratio has to be equal all the time. So, for example, if I take t equal to 1, every value of x between 0 and L has to give exactly the same ratio as if I took t equal to 2, or 5, or pi to the pi to the pi to the pi. Right? So that means the only way that two functions of completely different variables can ever be equal to each other is if they're constant. They actually don't vary in x or t. So that means that they have to be equal to some number lambda. And again, by convention, I'm going to put minus lambda here. Okay? So you'll see sort of why we do these things. We just do it to keep our life simple. All right? I know what to do here. I know that it's better to put the k down here. I know that it's better to put a minus here. Okay? So you're going to have to trust me on this. But this gives me two equations. So let's take a look at what my two equations become here. Well, the first one, so 1 is g prime over kg is equal to minus lambda, which is the same as g prime is equal to minus lambda k times g. That's an ordinary differential equation in t. And my second equation is phi double prime of x is equal to minus lambda phi. Again, what separation of variables did is turn this into an ordinary differential equation problem. That's why I said that you should probably know ordinary differential equations before coming to this. And really, this is kind of how we attack a lot of PDEs. We try to turn them into ODEs because we can solve ODEs much better than we can with PDEs. So let's do it. Let's solve. So let's do solving for g. Okay. Well, this is a fairly easy thing to do, right? All I need to do, this is an ordinary differential equation. It's a separable equation. You could easily figure out what the solution to this thing is. I'm going to let you maybe brush up on some skills here. It is a constant multiple of e to the minus kt. Okay? And this is going to work for all c and r. Any constant multiple is going to be a solution here. Sorry, and I forgot a lambda. Of course. Minus lambda. And lambda in R as well. Actually, it'll work for any lambda in C too. But, okay, that was the easy one. Let's do the hard one, or the more interesting one. So solving for phi. Okay, so first of all, we've got an ordinary differential equation. Phi double prime is equal to minus lambda phi. But there's more. Remember, this is the one that involves space. Space has boundary conditions, right? Time has an initial condition, which we will come back to later. But space has a boundary condition. So if u vanishes at the endpoints of this interval, if I have this form, it tells me that phi has to vanish at the endpoints of this interval. So, and phi of 0 is equal to phi of L, which is equal to 0. This is what's called a boundary value problem in ordinary differential equations. It has values prescribed at the boundary, and it's an ordinary differential equation. It's a problem. So now, if you recall your ordinary differential equation theory, there's going to be a bunch of different solutions depending on whether or not lambda is positive or negative or 0. So let's do this. Let's look at case 1. Lambda is positive. Okay. Then in this case,
I'll probably get back to watching that like on my own time, because we're almost to our second study session. So let me just turn off the study clock for a second. Okay. If you guys want to actually check out this YouTuber, his name is Jason Bramburger. So I will actually make a link for his for the video I was watching. He has like several videos. I haven't checked them all out. I just basically checked out his partial differential equations course. He has like one on ordinary differential equations, dynamical systems, mathematical modeling, a couple of them actually. So, and he also has one on regular calc too. So that and single variable real analysis. So I think you guys might probably find that useful. So actually, I will just basically copy and paste his playlist. So like if you're watching this on YouTube, I'll put his like links in the description down below, mainly on his YouTube channel and his playlist. So hopefully you guys can check that out as well. That way I can give him a little bit of credit, give him like the credit he deserves for putting these videos up. Anyway, so before we continue on with our next study session, and I'll turn the music back on, I will be right back. I'll just have to use the restroom for a quick second. Be right back. Okay guys, I'm back. Just one quick second here. I think I'll just touch up on my model a little bit, and I think we'll just shrink a little bit so that way it doesn't like cut off on screen. I saw it was like cutting off screen a little bit, but we probably won't need my model because we're getting into the next study section and working on the next couple of problems. So hopefully we can solve more problems this upcoming round. So we'll turn on the study timer and let's get into the next study session, shall we? Yeah, like even though like I haven't solved problems with differential equations or probably like gone through all of ordinary differential equations, I still like try to get my feet wet with mainly like getting used to like understanding the basics of it, like actually like hearing the information, the terms, and what exactly is it that the subject covers in the first couple of lectures, so I can understand how they teach it and how they basically try to get the students that they're instructing to understand the material. So I'm just going to jump around a bit because the first section is just basically sign substitution. I know I probably should do more problems with that, but we'll probably do that like tomorrow, because like I noticed with me, I sometimes do the problems like in a list, and I probably shouldn't do that. I feel like I have to actually like jump back and forth to see if I can actually like do different sections of different problems. So just forgive me for doing that. So we are given this, and x will be 8 sine of theta. Oops, not d. And then dx will be cosine of theta, meaning that we're going to be left with 64 sine theta square root, and we're left with cosine, then 8, and then we're going to be left with cosines, no, just regular cosine of theta on this side. Then we're going to basically multiply these together to give us cosine squared theta. Hey Don, how's it going? Don does math. What's the best part of your day so far, my friend? We're in our second study session. I don't know why I thought I was mispronouncing second for a second. I guess it's the math. But if you guys are not familiar with Don does math, he also streams math. In addition, he sometimes plays video games on his channel, so be sure to check him out. And he also has awesome vibes as well. So I'm pretty sure that you guys will have a lot of like problems that he can delve his mind into. And I just realized that I didn't multiply 8. No problem, Don. No problem. Anything I can do to help out a fellow math streamer / game streamer, because I game on my other channel. Like actually tonight we're gonna, like me and my friends are gonna do a podcast on my gaming channel. Not about video games, it's just basically about anything like life in general. It could be about anime, it could also be about games, it could be about basically anything for that matter. So, but I'm glad you're here, Don. I'm glad you're here. Oh, the other channel? Let me just type that in for you. So my other channel is my Uncle Talks channel. So I play video games there, in addition to like do my podcast there. Our podcasts only go every second Monday of the month, so there we go. So basically that's like the channel I go just to chill, relax, talk to you guys, as well as play games there. Games that either I'm interested in or just games like, you know. Oh, I guess that's you must have dropped a follow, Don, because I actually heard the sound alert for my other channel. Yeah, I don't know why that happens. I think it's because it's OBS, and OBS is like linked to like other options there. Yeah, I'll have to check out your streams over there too. Yeah, we're gonna have a podcast like later tonight, 8 o'clock Eastern Standard Time, and we're probably gonna do the podcast from like 8 o'clock Eastern Standard Time to 10 o'clock Eastern Standard Time. I don't know what we're gonna talk about, but we're probably gonna be talking about stuff that basically intrigues us, mainly. So where was I? Oh yeah. Right. Okay, so we have 64, so bring 64 out here. And we got cosine squared. And I think for here, 64, we'll just change it to theta, like this. And then we'll bring this 64.5 out here. And then, so 3 and 32. Then we're gonna do a typical U substitution with this. Then we'll just separate these out first. So sine of, yeah, we'll leave that. I could have just erased the 1, but I'm not going to. Oops. And then that would be 2 underneath there, so let's just bring this up so you guys can see it better. Then we're going to be left with theta plus, put a half up out here. Actually, we'll just make it nicer. I might be tutoring someone then, but I'll catch it if I can. No problem. I appreciate the follow, otherwise, Don. Much appreciated. So enough with that. And then 32 theta. And that would be sine of u. And then we'll just put a constant here, just to show that we're doing our due diligence. So 32 times that, and then 32. That would be 1, then you're gonna do 12, then that's 16. So 16 sine of 2 theta plus c. Then we're gonna have to change some things, I think. Because I think we have to convert it back to x, right? Let's see, we have x is equal to 8 sine of theta. So, do we have to convert it back to x? I think we do. Yeah, because like it started out as x, so it doesn't make sense to keep it in its theta form. Okay, so now we're gonna have to do the hard part. So we got x is equal to sine theta, so theta is equal to sine I don't like that 8. There we go. That 8 looks pretty good. So then 32. Looks kind of ugly. I really don't like the way it looks. That sounded so childish to me. It's like, ew, that looks kind of ugly. The reason why I say that is because it has the inverse signs, and I'm like, I mean, I don't know if I've ever seen equations looking like that. Yeah, because like the sign with the inverse of sign, right? When those two like cancel each other out in some way, and then you're left with like 2 times x over 8, or am I thinking that wrong? Because I get a feeling that the signs cancel each other out in the second term. They would, yes, but the two inside messes that up. Oh, okay. I mean, we could factor out the 2, I think. Right? Oh, no, because it's contained in the sign. Ooh, and we don't have any parameters for x, so you can use the double angle identity to fix that, though. Double angle. No, it's okay. It's okay, Don. Yeah, take your time. Take your time. I'll just look up what the double identity angle, because I actually forgot what that one was. This is a Lulu. Okay, so according to the double identity formula, we are left with sine of should move this to the side a little bit. So we'll erase that, then we'll do this. And then we also have a cosine of x. Sine. Oops. Dun, 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 dun. Okay, so I think these two would cancel each other out, according to what Don said. See, Don knows a lot more math than me, so he is basically, I guess, my, I guess you can say he's tutoring me in some ways, which I'm very thankful for. So, and we also have cosine, sine of, oh yeah, we shouldn't forget the c, just in case, and then we're left with c. Plus c. Okay, I wanted to make sure that I multiplied the 32 correctly. Because there was something in my head, it's like, you forgot something. And I'm like, hopefully I didn't forget anything that's nonsensical. mean, that reduced it a little bit. And I think that's all we can do. Yeah, because I don't think cosine and sine are gonna do very much. I mean, I could look at the answer, but I feel like I shouldn't, because it might deter me a bit. I mean, we can look it over just to basically like see if we did everything right. So we're working on problem number 17 over here. So let's see. Yeah, that looks good. Yeah, so we get the derivative here, convert that. So 64, that would be 8. If you take the square root, then basically turn that into cosine squared, which is under the square root, just turns into cosine. And then we multiply the cosines together, giving us that. I don't like the way that 2 was. There we go. So then we just decided to convert it to make it a little bit easier to manage without the square. Then we take that into 32, right? That we just basically did u substitution. And then basically we did that. Yeah, everything looks like we did everything to the right process. And I don't think we can reduce it anymore. So I'm just going to put this in a box, and hopefully that is correct. Because I mean, it looks like we did everything correctly. Although it is a very messy looking equation. But, you know, sometimes I mean, as long as you get the technique and you basically just apply it, I'm pretty sure that it won't be too much of a big hassle. So now, let's see what we got. So I think we should do one with a secant problem, because I haven't done, like, secant is usually the one that I don't do a lot of practice on. So I think we should go into the secant problems now. And then probably after that I'll do a tangent problem. So in this case, x will be equal to, this one is 81, so it's 9 secant theta, meaning that the derivative dx, oh crud, secant of, the integral of secant is it the, tangent plus secant x, or it should be theta. I think that's it. Oops. Integral. I always forget the secant integrals. They have it on the page, or do I have to go to the previous chapter? Maybe I have to go to the previous chapter to see it. I know they had a table. Here it is. So secant is secant plus, oh okay, it is, okay, it is that, okay. Usually when it comes to like sometimes I know you shouldn't memorize it, but at the same time, like, I feel like math, like when you start learning it, you kind of go accustomed to memorizing certain things until later you get into higher maths, and then suddenly you develop a way to actually derive it. I know memorization is not a really great thing, but at the same time, it's like there are times when memorizing it is much easier for me to remember it than trying to derive it to something else. Yeah, the way I kind of remember this is that I would think of like the strange ones that I have a harder time with. I would think that they're more complicated, and that's how I usually remember it. Usually. But I know memorization's bad, and like it's not really helpful. I mean, for me, it like since I'm still in basic calculus, like I feel as if like memorizing things makes it a little bit manageable for me, even though I know it's not really a great way to practice. Although this integral is going to look very, 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 very cumbersome. I will say that for sure. So we're left with 81 secant to the square minus, therefore, oh, I forgot the d theta there. Then we're going to be left with 9 on the outside, and then secant minus 1, so I'm guessing that's going to be tangent. Tangent theta secant. Therefore, we got 9 over 9 secant, then tangent on the bottom here. Yeah, because then it will be tangent squared. Yeah, because 1 plus tangent squared equals like secant squared. Okay. These 9s will cross out. So then we're left with tangent theta plus secant, then tangent theta. Okay, now, the challenging part, this natural log. Yeah, because the derivative of a natural log is I'm trying to remember, because like it's been a long time since I've done Calc 2, so I have to like ram my brain on actually trying to remember this. Because I don't want to do U substitution. I mean, I could, but I don't want to do it willy-nilly. I mean, hopefully I didn't make it harder for myself than it should be. I probably did, but at the same time, it's like, I don't think I see any other alternative. And I think I know secant is probably going to be the most complicated one, so that's why it's like, kind of like that. Oh, wait, I almost forgot. So, like, I mean, laws of exponents, it would be similar. So, if an exponent plus an exponent, it's also the same as multiplying both of them. Right? So, okay, I think we're getting a little bit close. The thing is, I feel like I'm missing something. I mean, hopefully that's right. Because I think exponents, if you add two of them together, it's the same as multiplying them both together. Yeah, because if it would be, no. I feel like we're getting so close. It's just that it's like there's something in my brain that is like not letting me connect it, and I'm like, well, I shouldn't blame my brain. I should basically like try to connect it in the way that it will naturally come, because like I feel like I've done that with the last problem, and I mean the last couple problems, and I'm like, I can get there. It's just that I just have to navigate it right. And if you guys like math or physics, and you're, I guess, if you find amusement or enjoy me like trying to strive to solve these problems, or you just need someone to basically be with, to like study with or be productive with, you know, drop me a follow if you can. It really helps me out, as well as like helps out the channel, you know, and we can build like a community of just being productive on the things that we want to do, whether it be art, math, physics, or anything in general that you're working on, like if it's on your computer or something like that. Or you could just have my stream on while you're just drawing in your sketchpad or writing your story. It's just basically just to get you guys to do a lot of things, like to basically like get through the things you want to be productive with. Because I know being productive is pretty hard. It's like on the tip of my tongue. I feel like I'm very, very close. But I could be going in the wrong direction, because that has happened to me a couple times. I thought I would be clever, and then suddenly, whoops, it doesn't work out. Excuse me, guys. Sorry about that. Okay. Ooh. It's like it's so infuriatingly close. I feel like that's how it is. I just don't know what is it that I'm lacking here. Maybe I have to take a look at the example they provide for secant. I'm pretty sure they had one where it's like it shows the log. This This one's for tangent. This one's for sine. Let's see, secant. Yeah, here's one for secant. No, wait. No, this is tangent too. Oh, here we go. B is for secant. Okay. Here we go. Oh no, this is a check. This is a quick checkpoint. I thought it was part of the example that they showed. Oh, I think this is it. Yeah, this. Oh no. This one's for sine. No, I don't think they have an example for secant. I thought they had one with this type of scenario, but I guess not. Oh, here we go. Oh wait, secant substitution. No, that's pretty much not what I'm looking for at this point. So we're working on what problem are we working on? What number? Oh, I forgot to write that number down. Well, it's no, that's not it. 25. So I think it's like up here. Yeah, you guys can see it now. 25. What the? There we go. I mean, can you split this up into the natural log of tangent and the natural log of secant? Let's drag this over here. But I feel like that doesn't help us as much. Oh wait, what am I doing? No, that's the integral, right? I think that's the integral of secant. Let me just double check. Yeah, that's the integral. My bad. That's not it. That's not it. That's why I was getting it wrong. I was like, oh my gosh, there's something here that I am messing up on. Okay, so it's not log. It's not natural log. That's the integral. That's why I'm struggling. See, guys, like, I make mistakes too. I make mistakes too. I think that's basically how I do problems. It's like, I think I'm supposed to do something, but then I realize it's the wrong approach. And it's like, oops, wrong thing. And I think the derivative of secant is tangent secant. Yeah, that's why it was a problem for me to solve. Okay, now I actually got what we're supposed to do. Yeah, because I just want to double check, because then that will turn into secant squared, and then we'll factor out the 9, and then, yeah, I think so. So these two cross out, and then we're left with secant, which will lead us to secant integral of theta, lead us to the natural log of tangent plus secant theta plus c. Okay, so the answer was actually much easier than I thought. It's just that I went a wrong turn there. I'm pretty sure that if you guys are watching this on YouTube, or like, you probably were like, no, that's the wrong thing. That's the wrong thing. I'm pretty, like, if you guys were like that, like, put it in the comments down below. If you're watching this on YouTube. If you're watching this on Twitch, you know, like, you guys are probably screaming at me. It's like, yeah, it's the wrong thing. Rewrite it. See, I'm not perfect. I'm not perfect, especially when it comes to math. Actually, like, the reason I hated math was because I made mistakes like that, and I would be, like, really infuriated. Because I lost points because I was remembering the wrong thing. And of course, tests, they time you, so it doesn't help much. Okay, so I did promise you guys a tangent problem, because we did do a secant problem. And we managed to navigate our way out of the woods with that one, so I'm just trying to triple check to make sure that I got everything right. Yeah, because then the square root. Okay, so I think we did that fine. Okay, tangent problem. Let's see. Let's try 33. 33 looks like it's fun. So square and then plus tangent. So x will be 2 tangent and dx, it will be secant squared d theta, meaning that we're gonna have 4 tangent to the square up here, and then, oh no, not x. Oh no, oh wait. Yeah, that's correct, yeah. What am I doing? It's just that so, and then that would be multiplied by secant squared. And then when we do this, 4 plus tangent squared, thereby letting this equal 2. Actually, we should write 8 here. Secant squared, then 2 comes out, and then we're left with tangent plus squared, which in turn equals tangent squared secant squared over 2 secant theta, right? Yeah, because then that'll be secant squared, and then basically the square root will make it secant. We'll drag this up, make it higher, and then I think we'll just turn this 4 and then we'll move it out. Right, like that, and then we're left with tangent secant, because the secants will cancel each other out. Alright, so now if we, let's see if we can split this. So if we split this up like this, I just want to visualize this, because I felt like I had an idea, but then I felt like, no, that might not be the right approach. Because if we did u for secant, the u would take over the secant, but then we're left with 2 tangents here. And we can get rid of one of the tangents. Now if we did tangent, then it would be squared. No. Let's see. I think I'm getting very, very close. Like, in my head. It's just that I'm trying to, like, maneuver around this last part here. Unless there was something I could have done. Wait. Oh, I think I see what I did. Okay. I think I know what I need to do now. Yeah, this is a problem with me, I swear. Like, so I think what we should do, I think I know what to do, but I could be completely wrong here. Oops. And secant, and then because it's 4, and then secant, and then secant. Okay, because you take the derivative of that, then there will be a u underneath. The problem is, it also turns that other secant. Oh, hello, we got... Hey, Bamboo. How's it going? What's the best part of your day so far, my friend? Yeah, we're so close. I just feel like the cumbersome part is just basically trying to visualize it. Because I can make this, the best part of my day has been talking to a coworker about his small town in Ohio. Oh, nice. That's really good. It's always great when you can have a great conversation at work. I know I can do this. Dang, we're running out of time. And ding, break time. But I really want to solve this problem though, because I feel like I'm so close to finishing it. Tangent squared. Because if I make this u, then this also becomes... Well, I mean, we can cross them out, but then we're left with a u on top of a tangent. Right, that doesn't help. Well, maybe we'll continue this problem tomorrow. That way I can have a refreshed mind and I can probably look at it like in a different way. Sometimes I'm like wondering, like, why is it that like a lot of people can do like a lot of problems very fast, but yet when it comes to me, I have to like solve it. Like it takes me 45 minutes to do like 2 math problems. This one I think we just did like probably like 1, and then we're like in the process of doing another one. But then again, maybe I spend too much time like actually just like thinking about the problem, which is probably good, but at the same time it probably is like a lot of time wasted for me to actually practice other problems. But I don't know, I'll let you guys judge. And if you guys are watching this on YouTube, you know, put it down in the comments below on like what I'm probably doing wrong in my study method, because I know I'm not the best. I don't have like really great study methods, but at the same time, it's like for me, when I try to focus on a problem, I try to like not go to the answer right away, but at the same time, you know, sometimes I spend too much time thinking about it. Maybe my struggle will help you in some ways. And it's like, I got the answer faster than you did. I'm like, you know, clap, clap, you know. Like, you can put it down in the comments down below if you got it way faster than me. But yeah, I think that will do it for today's study session. So thank you guys for joining me today. Like, for all of you guys that just arrived into the stream, apologies if you missed like the study bits, but you know, I also have another stream to do on my other channel for a podcast. So if you want to join me on that, you can join my Uncle Talks Twitch channel. So you can tune in onto like my podcast there, as well as me playing video games there. That's also another thing for you guys to get to know me a little bit more. If you're watching this on Twitch, you can, if you would be so kind as to follow my YouTube channel, because I post all my VODs there as well. So if you missed any part of the VOD, you can basically go into my YouTube channel and I will upload the VOD there, and you'll be able to catch what you missed. So you'll be able to see my progress. And if you would like to basically join our Discord server, you're more than happy to. If you're watching this on YouTube, the link to the Discord server is in the description down below. And it would also help if you like the video as well, if you're watching this on YouTube. Okay, so I think that will do it for today. Let me see if there's anyone streaming math content. I guess there's no one doing math content today, and none of the people that I follow are like online, so I guess we'll just end it for today. So thank you guys, and all the links are in the description down below if you want to actually access the links that I have provided for, you know, everything that from my streams to like any videos that I may have watched on the stream, or even the music that's on this video that you're watching, or stream, or whichever platform you're watching this on. So thank you guys, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys tomorrow. So take care, guys. Bye bye.